Alright, so here's where things start to get a little more interesting. We're going to be solving two-step equations. And it'll seem like it's more than two steps. Once you kind of simplify everything down, it'll be a little bit easier. So here I have 2x minus 4 plus x minus 7 equals 3 plus 1. It seems like a ton of numbers. Seems like how the heck am I supposed to solve this? Well, let's just take a little bit at a time. First, let's combine all of our like terms. I've used these colors to kind of help us see our like terms. I have x's here, 2x and another x. So, and then I have some constants here. So first I'm going to put my variables together. I have 2x. That basically just means x plus x. And then I have another x. So that means x plus x, x plus, well, let's do blue. Let's keep it color. X plus x plus x. So basically I have three x's. 2x right here, and then plus another x. So I'm going to write that as 3x by itself. And that just keeps it together. And then on this side of the equation, I'm only combining like terms on one side of the equation, the equal sign at a time. I have negative 4 and negative 7. If I add negative 4 and negative 7 together, negative 4 plus negative 7, two negatives is like adding two positives. 7, 8, 9, 10, 11, but it's negative 11 because they're both negatives. So I'm going to say 3x minus 11. And then on the right side here, this part right here, we did this part first, the left side first, and then on the right side we have 3 plus 1, and all that's going to be is whatever 3 plus 1 is 4. So now this looks a little bit simpler, looks a little bit easier. I have 3x minus 11 plus 4. What you always want to do is you always want to do any of the addition or subtraction first. To get you want to get x by itself. So I'm going to get rid of any addition or subtraction that I can get rid of or move. So I have negative 11. The opposite of subtracting 11 is adding 11. So whatever I do to one side, I need to do to the other side. So I'm going to add 11 here. I'm going to add 11 here. This ends up giving me 3x. These add to 0. So I could say 3x plus 0, but I'm just going to write 3x. I need blue. 3x, well, I'll write it right here. 3x plus 0 equals, and then 4 plus 11, that is going to give me 15. So when I think of this, it's going to be 3x equals 15. I guess I should keep that in a different blue. Now, so that was the first step, or the first after we simplified the first step. I need to get x by itself. This is 3 times x, and that's equal to 15. To get x by itself, I'm going to have to do the opposite of multiplying by 3. I'm going to have to divide by 3. So 3x divided by 3 and 15 divided by 3. Now 3 divided by 3 gives me 1, so this is 1x is equal to, and 15 divided by 3 gives me 5. I can just write this as x equals 5. X equals 5. And if I want to check this, I can just plug this x back in to wherever it shows up, wherever x shows up. So I'm going to say 2 times 2, I'm going to put parentheses everywhere the x is, and then minus 4 plus the x minus 7 equals 3 plus 1. Then I'm going to put this 5 that I discovered that x equals 5, and 5 right there. So 2 times 5 gives me 10, minus 4 plus 5 minus 7 equals 3 plus 1. So then this is just integers right here. 10 minus 4, let's do one more. 10 minus 4, I'm going to go left to right. 10 minus 4 is 6 plus 5 minus 7. I'm going to go ahead and just do these together also. 3 plus 1 equals 4. Let's do blue. 6 plus 5 gives me 11 minus 7 equals 4. And 11 minus 7 does indeed give me 4. 4 equals 4. They're both balanced. This checks out. Let's try another one. Before we try another one, let's take a look if we had to draw this as a quick model. All I would say is 2x. I have an x. I have an x. I have another x right here. Minus 4 plus 7, and that's going to give me minus 4, minus 7. Then that gives me some negative 11. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. That gives me negative 11. And then on this side, it's 3 plus 1. And then I'll just do blue for that. No, I did blue already. 3 plus 1. So 1, 2, 3 plus 1 gives me 4. And then if I wanted to draw a picture of this, this would end up being 3x minus 11 plus 4. I would just have to add 11 and then divide by 3. So I guess the way I can do that, let's see, add 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I divide by 3, so I'm going to get groups of 3, and one group of 3 right here, one group of 3 here, 3, 3, 3, 3. One group of 3 over here gives me 5 groups here. 1, 2, 3, 4, 5. X was equal to 5. And so it matches, it works out, okay? So this model helps us kind of keep in mind what we're doing and how we're keeping things balanced. All right, so this one looks a little bit more complicated, but just let's take one step at a time, and then it'll be all right. So this is a distributive property one right here on the left side, and then I have a few other like terms on the right side. So I'm just going to solve out this distributive property part one first. So I'm going to say 3 times 2x. So I'm going to just say that is 3 times 2 is 6. So that's 6x, because that's basically like saying 2x, 2x's, x plus x, plus another 2x, plus another 2x. So that's 1, 2, 3, 4, 5, 6. That's how I got 6x. Okay, this is 3 times 2x, and then 3 times 5. I'm going to add that. 3 times 5 gives me 15. So 6x plus 15. That's what I've got for the left side. There's no other like terms together that I can put together. And then I have 4x, and then a negative x over here. 4x, that's 4 x's, 1x plus x plus x plus x, that's 4x right there. And if I take one of them away, minus x, I'm just left with 3x. So I'm going to combine those two like terms, the x's with my variables, 3x, and then I have two constants here. I have a positive 7 and a positive 1. And that gives me a positive 8. So I'm going to just say plus 8. Okay? So here's what I need to do. I need to get x's by themselves. So I need to move some stuff around. I have a positive 3x here and a positive 6x. What if I subtracted 3x from this side? Take 3x away. If I take 3x away from this side, that means I need to take 3x away from this side, minus 3x. And then 6x minus 3x is going to equal 3x, because 6 minus 3 is 3. 3x plus 15 on this side. And then on this side over here, the 3 minus 3 gave me 0x. I don't have to, I'll write that just in this part right here, but you don't really have to write that normally. 0x, just so you can see, plus 8. Okay, so now I've got x pretty much all by itself. Let me just rewrite that without the 0x. This is 3x plus, let's see, plus 15 is equal to 8. It's equal to 8. Now I've got to get this x by itself. The way I need to do that is anything I can add or subtract, I need to do that first. So if I have a positive 15, I'm going to subtract 15. That's the opposite of adding 15. If I subtract 15 from this side, I need to subtract 15 from this side. So that leaves me with 3x over here. That's plus 0. I'm not going to write it this time. 3x plus 0 is equal to 8 minus 15. The difference between 8 and 15 is 8, 9, 10, 11, 12, 13, 14, 15. It's 7. But my larger number is negative, so that's going to be a negative 7. So 3x is equal to -7. Now, if I need to get x by itself, this is 3 times x is equal to 7. So the way that I'm going to get it by itself is to do the opposite of multiplying by 3. I'm going to divide by 3. Divide by 3. And 3x divided by 3, that's going to give me 3 divided by 3 is 1. So that's just going to give me 1x. I'm just going to write x instead of 1x. 1x is equal to, oops. And this is a fraction. I can do a few things with this. I can do -7/3, or I can even, I'll probably keep it as a fraction. If I was asked to put it into a decimal, I would just do -7 divided by 3, and then I would divide completely. 3 goes into 70. Well, 3 goes into 7 twice, -6, and that gives me 1. 3 goes into 10 3 times, -9, that gives me 1. So it looks like it's going to be repeating, 2.33 repeating. So x is equal to 7/3, or if I wanted to write it as a fraction, I could say or 2.3 repeating. Okay. Usually you'll leave it as a fraction, but just in case they ask you to write a decimal, that's how you would do that. If you're going to draw this one, you can just draw it once you get down to the simplified version where it's 3x plus 15 equals 8, where you have 3x, 1, 2, 3, and each one of these is x, plus 15, and then it would just be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That is equal to 8. 1, 2, 3, 4, 5, 6, 7, 8. And then to show that you're subtracting the 15, you would basically cross each one of these out, and then get rid of these 8 right here, but you also end up getting, what was it, -7, 3, 4, 5, 6, 7, 4, 5, 6, 7. And then you just divide both sides by 3 right there. 3, and then that's one group of 3, another group of 3 with 1 left over. So it's not the perfect picture, but if you had to model it, this is what it would end up looking like.